Welcome back, students! Today, we are taking our calculus skills to the next level by finding the derivative of the inverse cosine function, y equals inverse cosine of x, using first principles. Let's jump right into the derivation. We start by defining our main function. Let y equal the inverse cosine of x. By taking the cosine of both sides, we can rewrite this as x equals cosine of y, which becomes our equation 1. As always, keep an eye on our domain restrictions for the inverse function to remain valid. Next, let's introduce our small increments. When x changes by a small amount, delta x, y will change by a corresponding small amount, delta y. Substituting these variations into our function gives us equation 2. X plus delta x equals cosine of y plus delta y. Now we isolate our change in x by subtracting equation 1 from equation 2. This leaves us with delta x equals cosine of y plus delta y minus cosine of y. To turn this difference into a product, we apply the standard trigonometric difference of cosines identity. Paying close attention to the angle subtraction order, our expression simplifies to 2 sine of 2y plus delta y over 2 times sine of minus delta y over 2. Because sine is an odd function, sine of minus delta y over 2 is equal to negative sine of delta y over 2. We bring that negative sign to the front. Now, to structure this as a rate of change for our derivative, we divide both sides by our increment delta y. Let's apply the limit as delta y approaches 0 to both sides. The left side yields our derivative with respect to y, written as d over dy of x. On the right side, we separate the terms to exploit our fundamental limit theorem, where the limit of sine of x over x as x goes to 0 is equal to 1. We balance our fraction by inserting a 2.5 into the expression. Evaluating our limits, the special sign limit reduces to 1, and the remaining sign term simply becomes sine of y. The factors of 2 cancel out, giving us d over dy of x equals negative sine of y. Since our ultimate goal is to find d over dx of y, we take the reciprocal of both sides, resulting in d over dx of y equals negative 1 over sine of y. To express this completely in terms of x, we pull up our classic identity. Sine squared y plus cosine squared y equals 1, which means sine of y equals the square root of 1 minus cosine squared y. Recalling from our very first step that cosine of y is simply x, we substitute it right back into the denominator. And there you have it. The final derivative of inverse cosine of x is negative 1 over the square root of 1 minus x squared. Thank you for watching. If this breakdown of first principles made things clear, don't forget to like, subscribe, and share. See you next time for more calculus masterclasses.